Okay, welcome back for the next part. I think we're up to part 4. So in this case, we're looking at nonlinear inequalities, and there's a couple of different approaches to this for the purpose of understanding what this actually means. So what this is doing here is giving linear factors, and the linear factors represent a quadratic. So in actual fact, the interpretation that we're looking for is this, is to say, what are all the values, please, where the quadratic is less than 0. So in order to help us understand that, we're going to plot this. Now I'm going to do it as linear factors. I could do the expansion and write up the thing there, but I'm going to put it in, well, actually I'll do that. X plus 2, x plus 1. So we do the FOIL expansion of this. First, outside, inside, last. So we get x squared plus x plus 2x plus 2, which is going to be x squared plus 3x plus 2. Now we don't know anything about that. We can use our learned techniques about that. But what it'll mean is that we can understand that it's this quadratic. But now we've introduced this idea of asking another question. What's happening when the curve, what are the points where x is bounding the less than 0? So I'm going to put in the factors as x plus 2 and x minus 1. And even if I just do that without any other part, it'll draw the quadratic for me, and it's done the expanded form of the quadratic, which matches what we did. Here it is. Okay. Oh, I did minus. Look at that. I did a plus. So there, Jason's done it again. I'm a genius for that, aren't I? X minus 1, so x squared minus x, Jason, plus 2x minus 2. Here, Jason. Minus 2, and that'll be just x, won't it? So we can get rid of that 3 altogether. Gee, we gotta watch this guy. Okay, so plus x minus 2. So let's have a look at that. There you go, plus x minus 2. So what it's saying is, what are the values where x is less than? Now, it's quite contradictory to go and then embark on a really difficult journey to establish that. Okay? Simply because it's being inserted in inequality. I mean, visually we can see it. It's quite clear that the roots of the equation, the solutions of the x-intercepts of the equation, the roots of the polynomial, are the points where it's below 0. It's that little segment underneath there. Or in this case, it's a bit bigger because of the numbering scale. But in a normal looking scale, it's this smiley face underneath the x-axis. That's all the y negative values. So we can just solve. We could just solve these equations. And we could test, we could do that. We could just solve the, well, I don't need to solve it because they're already done. I mean, this is this factorised form. The factorising is being done. So therefore, x is equal to negative 2 and positive 1. Let's check that. Is that looking like negative 2 and positive 1? Yes. So in a way, we've established without much thought. But the technique for dealing with the quadratics varies depending on the curriculum system that you're using. And so what we want to do is at least have a little bit of a try at something different. Okay? So what I want to do is I want to use an interval notation and test some values. So we've got minus 2 and 1. Now because it's less than, we better put circles. Okay, and what we want to do is break these up into regions. This is a very old-fashioned way to do this. But anyway, that's not taught in the HSC. But anyway, it's just a way of seeing how these values will pan out. Okay, and I'm just prepared to do one example using this method. So in this interval here, we'll have x is less than minus 2. In this interval here, we'll have x is between -2 and 1. And over here, x will be greater than 1. So we're really looking at it through the lens of inequality. Okay? Really trying to understand what's happening through the lens of inequality. Okay? So let's test a value. Say x is -3. That's less than -2, isn't it? So if we put it into the function, -3 plus 2, -3 minus 1, is that indeed positive or negative? We'll check. So we can do the multiplications. So -3 plus 2 is -1, -1 minus 1, -3 minus 1 is -4. Minus times a minus is a plus. Look at that. +4. So this interval is up above the 2. So just testing the value and saying, if I do this, the -2, anything tested on this side gives us a plus. Okay, it gives us a plus. Anything tested in here, so we could test 0. Say test 0. So put into our equation, we have 0 plus 2 multiplied by 0 minus 1. And so we would get 2 times -1. And we would end up with a big minus, -2. Oh, -2. So it's saying anything in this interval is negative. Okay? And then again, say x equals 2. And so we would put in 2 plus 2 and 2 minus 1. So we'd get 4 times 1, which is a plus. So again, it's going off as a plus. The bit we're interested in is this bit. Okay? We're interested in being in the interval between -2 and 1. So this represents the solution to this inequality. Okay? So we're looking for a common sense answer to the question, because this is x equals 2. That is the version of the equation that's equal to 0. So they go together. But we're not doing an equals, we're doing an inequality. So that's why this is an appropriate answer to match that. And fleshing these out is not straightforward. Okay? Fleshing them out is not straightforward. So I encourage you to think carefully about these nonlinear inequalities, because they can be quite taxing. So just be mindful of that, please. Okay? All right, the next thing we want to consider here is if we bring the quadratic over, so we bring that over, we will get a quadratic that looks like this. And that's now in a form that we can, like the previous version, we can say what's happening with comparison to 0. So what's happening on the x-axis here. Okay? So if we go ahead and solve this, that would be the next step. Okay? To solve this. Now, I'm happy for you to use the quadratic formula. Okay? And that would be okay. So we get minus b plus or minus the square root of b squared minus 4a. So you can use technology over 2a, or you can just be careful now. Minus 1 is the coefficient, plus or minus the square root of -1 squared minus 4 times 2 times -3. So be careful, put that in a bracket. And it's 2 times 2. So we've got +1 here. Minus times a minus is a plus. So this is a plus quantity underneath here. So we can bring it back here. So we've got 1 plus or minus 1 minus 4 2 is 8, 24. Plus 24 over 4, which is 1 plus or minus 25. We know that's 5, so 1 plus or minus 5. Now split your fraction, you can do that here, or you can just do 1 plus 5 is 6 over 4, and 1 minus 5 is minus 4 over 4. And so the 6 over 4 is what? 3 over 2, 1.5. And 4 over 4, negative 1. So there are our x values. Okay, so our x values are 3 on 2 and negative 1. So we can take our interval and we can put 1.5. Actually, that would be more sense under here, wouldn't it? Sorry, I don't want to confuse that. That just looks wrong over there. I was doing it up here, see, so I just transferred it. So we can do this as minus 1 and put this down as a testing area, and 1.5, which is 3 on 2. We can put that as a testing area, and we can check these. And again, I say this is an older way of doing this. Okay, so if we test the values now, bring the equation down and substitute values in. Okay, so if we test values, so we've got x is less than minus 1 because we're looking at the interval. The interval is minus 1 to 3 on 2. So somebody's having a birthday in there, and x is greater than 3 on 2. So that's that testing area. So we'd say minus 2, x is minus 2, say x is 0, and say x equals 2. Okay, so x equals 2. So we've got on the left-hand side, if we go and process these values using function notation, okay, and 0 and 2, we will get our values. I'll leave you to do that. That'll be a positive, that'll be a negative, and that'll be a positive. Okay, so what that tells us is that on the graph, it's going above and below. All right. So from that, then we can pull the inequality. We can clearly see that what's happening is that where we have our minus 1.5, minus 1, and minus 3 on, and plus 3 on 2, so minus 1 and 1.5. We can clearly see that this section down here is the negative and the positive. Now, which one applies? Which one applies to these? Okay, so we need to get the solution for the form. So in order for this to be true, it's got to be positive, so we're going to have everything from that point on and everything from that point on. So x has got to be less than minus 1, or x has got to be greater than 3 on 2. Okay, so it's an OR result. So that is the solution to this inequality. Okay, so we need to be mindful that we're making these correct assumptions, the inequalities. Some of these are very challenging and they can be problematic in solving, so we need to be a little bit careful of that. All right, there's a couple of others to do. So I'm only at 13 minutes, so I'm going to keep going with it, and I'll do these couple as well. Making y the subject, so subtracting x squared from both sides. Because it's a plus minus, doesn't matter. Plus 4, so that's a simple arrangement. Now it's a two-termer, so that means it's on the y-axis, it's symmetrical about the y-axis. It's an upside down at 4, okay, and it's going down like this, okay, and it's saying that the curve y is greater than minus x squared plus 4. So we did this with Wolfram. So I'm going to plot that again. So y is greater than x squared plus x squared minus x squared plus 4. So let's have a look at what that looks like. It's greater than. So it's all the values y greater than the boundary point. Okay, greater than the boundary point. And of course the other thing I have to do, isn't it? I have to make those dots. I have to make those dots because it's not inclusive. So they come down like this and down like this. So it's all the values greater, all the values y greater than our function value. So all the values y greater than the function value. Okay, and that includes the values that slip down here. So they're still greater than the function value. Remember, this goes on infinitely. Okay, so it includes these areas here. All right, so getting used to this kind of inequality is useful for the future, but for the time being, I've said to you quite adamantly, I don't want you to fret this. All right, so making y the subject again. So we might plop y over that side. What you do to one side, you do to the other. We might put the 2 over there. Okay, so we'll have minus x squared plus 2x minus 2 is less than or equal to y. Now, for the sake of convenience only, we're not breaking any rules or invoking any rules or using any rules. Purely for convenience sake, we're putting it in this form. So now this is an unknown solution set that we need to work out. So the easiest way to do that is to check the discriminant or complete the square. Either way will be fine. So if we complete the square, minus x squared plus 2x minus 2 is equal to 0. I'm going to divide by minus 1. So I'll get x squared minus 2x plus 2 is equal to 0. I take the coefficient, minus 2, and halve it, and put a circle around it. The scaffolding is square it. Minus 1 squared is 1, so that's our square number. That goes together with this one. So that's now a perfect square. We also want to remember that we added 1, and don't forget your plus 2. So minus 1 plus 2 is 1. So that's plus 1. And this is x and minus 1 equals 0. So we're just going to work out the points at the moment. But what do you recognise? This is in this form. Now remember that I've modified it, so be careful. It's sitting above. Okay, it's sitting above. Now in actual fact, the equation is negative, so that means this is flipped around. So in actual fact, because I did this step, we have to do minus 1. What ends up happening is we get minus 1. So there are no solutions. But that doesn't change this idea of inequality. Okay? It just means that in this inequality, all of the values are graphically looking like this. Okay? All of the values are looking like this. So what we then have to do is find some points that help us decide what the values are going to be that make the inequality true, and they would be the vertex points. They would be where it cuts the x-axis, so that's minus 2. The vertex would be minus b on 2a, so minus 2, so that's negative 1, isn't it? So that's negative 1. Negative is a positive, so that's 1. And then we put the values in at 1 and negative 2. Well, we know what the negative 2 value is. It's the x is 0. Sorry, when we put that in, we'll get negative 2. That makes perfect sense. So that pair there is 0 and negative 2. And when we put the 1 in, we'll get a negative 1. So that point there is 1, negative 1. Alright, so these are very complicated, and so I don't want you to be too bothered by these. Alright, so I'm going to come back. That's 20 minutes. I'm going to come back and start on the quotient form. Let's see what they look like.